Well, I think we can start. This is group 30 and we are presenting our project. First of all, we shall start by introducing the members on the team. So you should start introducing yourselves. First of all, yeah, let members start introducing themselves. I think we can start with Benjamin.
Good evening, everybody. My name is Chori Benjamin. In this project, I'll be playing the role of a mechanical analyst and dealing with the testing bit of this project. Let me hand over the microphone to the next participant.
Good evening. My name is Linda Sophia, and I'm responsible for networking and troubleshooting.
And the third person.
Good evening, everybody. I'm Kauma Joel, and I'll be the firmware developer. Then I'll be dealing with the coding, and yeah, basically I'll be dealing with the coding.
All right, thank you. A good evening to you all. My name is Watala Alexander Mark, and I'm the project manager of this project. So on behalf of Group 30, I'll be presenting and taking you through the entire project and defining the problem statement and giving hints on how the project is going to be implemented. Below are the contents of the presentation. First of all, I'll start with the introduction. We have the introduction, the problem statement, related work, research questions, objectives, methodology. This is basically the system architecture and how we are going to implement the project. The experimental results, conclusions, future research, and the references. Let me begin with the introduction. Drones are widely being used in a number of fields. Applications of drones range from filming, videography to robotics. Drones are generally costly in purchase, and there is a huge risk of damage while flying a drone. That is why drones are still not a very common gadget. In the world of might and superiority over who is controlling and leading this world, technology advancement plays a big role. Therefore, here we present to you a micro drone with a proximity alert system using LiDAR. Basically, LIDAR stands for light detection and ranging. This drone is to consist of 4 motors with propellers with Arduino Pro Mini, EVO controller, and a LIDAR sensor and buzzer. Basically, these are the components which are going to make up our project, our drone system. Therefore, these components will interact with each other so that the drone can operate successfully. Let's go to the next slide. Our next slide talks about the problem statement. In brief, the major problem associated with drones is that they need a lot of clear space to fly and cannot be flown in dense forests and areas with many trees due to a huge risk of damage while flying. When you look at the current drones, the major issue with them is that you cannot fly them in those tight places, even indoors. You need clear space without obstacles so that it can operate successfully. Therefore, to solve that problem, we shall come up with a drone, a micro drone, which can be able to detect obstacles to avoid collision using LIDAR system. LIDAR will be the technology which will be used to detect the obstacles. Here is the related work. We have reviewed some of the literature and online resources regarding the work we are going to do. According to our research, LIDAR sensor for autonomous vehicle, authors Ife Cairo of the institution Independent University Bangladesh stated that automotive radar and LIDAR sensors represent the key components for next generation driver assistance functions. And this was by Jones in 2001. In contrast, LIDAR sensors show large sensitivity towards environmental influences. For example, snow, fog, that both sensor technologies today have a rather high cost level, forbidding their widespread usage on mass markets. Then lastly, advanced driver assistance systems are now the objectives. These are the main objectives of our project as to why we are to do this project. To build a micro drone that can detect obstacles within the air and determine the proximity of the obstacle so as to avoid collision. This will be basically using the LIDAR. LIDAR will be the technology. Next, to build a drone with a LED and buzzer indications per obstacle. Basically, our drone will trigger an alert when it encounters an obstacle. And our micro drone will not auto avoid the obstacle, but it will trigger an alert. It will trigger an alert to the controller so that he can change the direction of the drone. Next, then to build a small size and low cost drone. Our research questions: what is the benefit case of using the LIDAR technology from logical and economical perspective? What does drone LIDAR measure? What can drone LIDAR be used for? How much data does drone LIDAR generate? Where can you fly the drone? Then how do I access the drone data? Then the next page, the next slide, it's our methodology. To accomplish the above objectives, we shall use the following hardware and software: Arduino Pro Mini, F3, EVO controller, leader module, buzzer, drone controllers, propellers, battery, switches, drone body, connectors, screws, and fittings. The mini drone consists of 4 drone motors. Below is the block diagram. The 4 motors and the leader module and the control system and the buzzer. Then the expected results, this graph below shows the velocity in the world frame and the time for the travel of the drone. And on the next page, it shows the positioning of the drone and the height where it's flying and the time it takes. Then the next page, the next slide is our conclusion. The project aims at producing a working prototype UAV with the available resources for demonstration. The drone should be able to detect obstacles using LiDAR system. We expect to acquire more knowledge and insight into the advancement of drone and other advanced technologies that require elements of computer science like artificial intelligence and hardware programming. Our future works, the drone will be enhanced with the capacity to track and identify the type of objects. The drone will be enhanced with the capacity to determine the distance and size within. Lastly, it's our references. Laser Systems and Applications by Chondri, Michael D. Basically, this was in the Robotics and Automation magazine, which was published in 2010. Yeah. This marks the end of our